Now, I'd like to introduce Lindsay Olson, the next speaker and part of the organizing committee to this event. Lindsay was Fermilab's first artist in residence, whose contributions over the years and continued support have helped develop the program. Her excellence in communicating science and creatively visualizing concepts seems to be limitless. Lindsay considers herself and her art ambassadors for high energy physics by exhibiting artwork, speaking engagements, and writing articles. Lindsay is a member of the Textile Society of America and has taught in the Fashion Studies Department at Columbia College for over 20 years. So thank you very much.
Thank you, Georgia, for that lovely welcome. I'll get my slides set up.
Okay. Whew.
Okay, so Georgia has given you a brilliant introduction to just what kind of place it is to work at Fermilab. So inspiring from not only the science perspective, but from the art perspective. Such a wonderful history. So being the first AIR at Fermilab was actually one of the coolest jobs I've ever had. And here's how one of my very best days started. After hours of training, I strapped on my dosimeter and stepped into the 4-mile-long particle accelerator that uses 1,000 superconducting magnets to steer and control mysterious particles called neutrinos. The dosimeter measures radiation exposure, and I was beginning my workday as Fermilab's first artist in residence. I make art about science, and my work takes me out of the studio to places like this, a cavernous ring of equipment designed to accelerate tiny bits of matter at near the speed of light. Here, scientists want to crack open the secrets of neutrino, and I want to explain it through art. For many people, science seems like an insurmountable subject, and one of those people included me. But all this changed when I realized that I could use my art training to learn scientific concepts. When Georgia invited me to help her establish the residency, we both had a goosebumps moment in this very space, in the art gallery. We both saw the potential of using fine arts to connect the public with high energy physics. And the idea of a Fermilab AIR, however, did give me pause for a moment or two. I wondered if I would really be able to learn enough science to create meaningful art. What I soon learned was that Fermilab has this long tradition of supporting collaborations with artists, and it's part of a robust outreach program filled with trained docents, a tricked-out YouTube channel, a visual art staff, and a wonderful group of writers. It can be challenging working across disciplines, but many people graciously shared their time and expertise with me during the residency. My work began with an understanding of the basics of the Standard Model. The Standard Model is to physics what the periodic chart is to chemistry, but instead of dealing with atoms, the Standard Model expresses life on the subatomic realm. The model describes life inside protons and neutrons. One of the biggest obstacles I had to learning about high energy physics was accepting how particles behave in the quantum realm. It's counterintuitive to the ways in which we perceive reality. And life in the quantum realm is so weird that you don't need illegal substances to completely blow your mind. I struggled to learn this material until I figured out that I had to make space for both versions of reality. The reality I experience through my senses on a daily basis, and the reality physicists have discovered on the quantum scale. One example among many of this dual view of reality is that things that appear solid to us are in fact made up of fields of wiggling, jiggling particles. Many artists use oil paint, watercolor, and other traditional materials, but to create my art, I want to figure out a way to have the least amount of distance between the art and the viewer. So everyone uses textiles in their daily lives, and creating work from them felt like a natural choice. The study of physics is ancient, and I wanted to use colors that suggest antiquity. So I've included a democratic use of high-end silks, laces, and workaday fabrics like denim and canvas. I also chose blackboard paint because blackboards are ubiquitous around the lab, and whiteboards as well. They're everywhere. They're in offices, in hallways. There's even one near the art gallery on the second floor in Wilson Hall. So after working on these pieces for a few weeks, I brought some artwork in to show Dr. Don Lincoln, senior scientist at Fermilab and my scientific advisor. He looked over the pieces in a kind of a, no, that's nice kind of way, and I pointed out all the fundamental particles that I had included, and then I asked him to find the Higgs particles in the pieces. So he was looking and looking and looking, trying to puzzle out where I had put the Higgs particles. When I pointed out that I had embroidered them into the background to match the background, I camouflaged them. The Higgs particle was predicted for over 50 years before it was experimentally confirmed, and I wanted the artwork to reflect just how hard it was to discover this particle. Don was suddenly very into the art and rewarded me with a huge smile. In the middle of this particular piece, I've added some blank placeholders for the discovery of new particles. But even this might not be enough to save my artwork from obsolescence. One experiment at Fermilab, the muon G-2, is providing mounting evidence that tiny subatomic particles seem to be disobeying known laws of physics. This new finding might eventually lead to a dramatic breakthrough in the understanding of particle physics. I have to accept that obsolescence is an occupational hazard for those of us with a science-based art practice. At Fermilab, scientists study a group of particles called neutrinos. Our universe is permeated with neutrinos. They're nearly massless, neutral particles that interact so rarely with other matter that trillions of them are passing through our bodies each second. In this piece, I've constructed a curtain that suggests a kind of theatrical space, a way to present a series of these mysterious particles. Subtle shades of silver, steel, and gold represent the three flavors of neutrino particles. Scientists hope one day to discover why these particles oscillate between these three flavors. Neutrinos emanate from the Earth, from the Sun, they arrive from the distant cosmos, and neutrinos are manufactured at Fermilab that begins with a sophisticated technology and a small bottle of hydrogen. This piece portrays the billions of neutrinos in the beam as an elegant cascade of metallic fibers. In this piece, and in this one, I'm using the visual metaphor of nets to suggest how detectors capture images of these rarely interacting elusive particles. The art borrows techniques used in high fashion to project an image of dark glamour. Here, the detector is represented by velvet squares joined by lines of beads in three subtle colors. I'm again using the three colors of seed beads to express the dynamic nature of neutrinos. I was interested in learning about the science of high-energy physics, but I was also curious about the actual experiments. I was given permission to undertake rigorous radiation safety training in order to accompany operators into the guts of the experiments. I had a privileged view of not only the hardware used in these experiments, but the people who maintain and operate them. Inspired by my visits to the underground neutrino experiments, I created a series of drawings that represent the powerful magnetic forces that steer and control the neutrino beam. I've used wet-on-wet ink here, which is difficult to control, to express the magnetic forces. I wanted these drawings to look slightly out of control, because controlling particles that all carry a positive charge is not easy. Having the chance to both plan and participate in the festival has given me the opportunity to put into practice the idea that the arts, all of them, poetry, dance, visual arts, videography, and music, all contribute to our understanding of and appreciation for the beauty of the universe. And now I want all of us on the festival planning committee and our wonderful presenters, we all would like to let you know that you don't need a PhD to fall in love with physics.